Okay, so today we are going over our second lesson in the ionic and covalent bonding unit. After today, we're going to be able to write formulas for ionic compounds and explain what an empirical formula is, which should be simple because we did it in the moles unit. And we will be able to list the properties of ionic compounds or ionic bonds, and we're going to actually draw out how the elements bond with each other using electron dot diagrams. So here are the properties of ionic compounds. So the ionic bonds are very strong and they are solid at room temperature. So for example, these two, okay, they are solids at room temperature, they are crystals. And they have high melting and boiling points, and they are made out of a metal and non-metal. So for example, the blue one here is made out of copper, which is a metal, and chloride, which is a non-metal. So they're made with metals and non-metals. The white one here is also made with a metal, which is sodium, and a non-metal, which is chlorine. They don't, in this state right now, okay, these two do not conduct electricity. However, if I were to pour water in them and dissolve them, so if I were to pour water and kind of crush and stir it up and dissolve them, that would be considered aqueous, so dissolved in water, and then they would be able to conduct electricity. And we will do a lab over that later this unit. Okay, so let's do an example of how these things bond together. So sodium is here and fluorine is here. So this is our metal and this is our non-metal. And remember the trend we learned about last lesson? We're going to ignore the D and F block today and only deal with the S and P block. So the everything in all the elements in group 1 will have 1 valence electron. All of the elements in group 2 will have 2 valence electrons. Skipping these, we have to do electron configuration for these, which we know how to do, we're just not doing it today. And then all of the elements in group 13 will have 3 valence electrons, and then the trend just continues until we get to the noble gases with 8 valence electrons. So let's do sodium and fluorine. So sodium, Na, and fluorine. Why did I do that? Sorry. Okay, so Na and F. So these are our two, atoms. Sorry. There we go. These are our 2 atoms that we are going to use, and this will be our metal and this is our non-metal. So if you'll look here, sodium has 1 valence electron. So we're going to draw sodium's 1 valence electron, and then fluorine is right here and it has 7 valence electrons. So we will draw fluorine's 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. So I like to leave the opening close to where we're going to be drawing our arrows. So what you're going to do for ionic bonding to show where the electrons are moving is you're going to circle the electron you're going to move. So remember, ionic bonding is transferring of electrons, not sharing. So there is no line, there is no bonding here. We're just drawing this electron is going to be donated here and moved here. So that's how you would show your work if I ask you to show your work. And this would have 8 valence electrons, and then this one would be stable as well. It would actually have 8 valence electrons. It would be isoelectronic with neon. But we're not going to draw them. So what we would do is, since this became stable with just 1 electron donated, we only needed 1 sodium and 1 fluorine. It's very important that you write the metal first, always. Okay, we always write the metal first and then here. So that's it, we're done. Okay. Moving on, we're going to do magnesium and chlorine. So magnesium and chlorine. So if we'll look at the periodic table, magnesium has 2 valence electrons. So 1, 2. And chlorine has 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. Okay, so we're going to show this electron being donated to chlorine here. This chlorine has 8 valence electrons. It's stable. However, magnesium is highly unstable. It still has 1 electron it needs to get rid of. So what we need to do is add another chlorine ion, okay, with 7 valence electrons. And then the magnesium will be able to donate its second electron. Now this one's stable. This has gotten rid of all of its electrons, and then this one is full. So the actual, the actual formula will be Mg. There's only one of them, so we don't use a subscript of 1 whenever there's a 1. It's just assumed. And we have 2 chlorines. So that's the formula for magnesium chloride. Okay. All right, so let's do, I think it's the last example, aluminum and sulfur. So we have aluminum and we have sulfur, okay? So we have to look at the periodic table, and we need to find out how many valence electrons aluminum has. So aluminum is here, so it has 3 valence electrons. Okay, sulfur has 6 valence, sorry, you can't see. Sulfur has 6 valence electrons. So 1, 2, 3, 4, 5, 6. Okay. So now we're just going to bring electrons from the metal to the non-metal until they're both stable. So we have aluminum here, and this electron will go here. So this sulfur is stable, however, aluminum is not. Okay, so we need to add another sulfur. We need to add another sulfur, so here. Sulfur had 6, 5, 6. Okay, so this electron will go here. But now we still have this vacancy here to fill, but we only have 0 electrons. So now we have to add another aluminum with 3 electrons. Okay, so this electron will fill here. Now aluminum, annoyingly, still has 2 electrons we have to fill. So sulfur is happy now, and this one is happy, but we are not happy here. So we need to add another sulfur. 1, 2, 3, 4, 5, 6. Okay, and then we will bring this electron here and this electron here, and then sulfur will have 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. So it's happy. This one has gotten rid of all of its electrons, so that's it. We're done. So then that would be the actual formula would be Al. We always write the metal first, and we have 2 of them. So Al2, S, and we have 1, 2, 3 of them. Al2S3. And that's how you would solve that. Empirical formula, so it's just the reduced formula.